Welcome to this explainer. Today, we're opening a cosmic cold case. We're diving into a mysterious little system in the constellation Cancer, specifically NGC 2777, a really peculiar spiral companion to a much larger galaxy called Caldwell 48. And honestly, this weird little galaxy challenges almost everything we thought we knew about how the universe works. This isn't just about a weirdly shaped collection of stars, it's about a fundamental mystery regarding the timeline of creation itself.
Let's kick things off with a massive question about our universe's history. The Standard Model tells us that galaxies formed billions of years ago, right? Basically shortly after the dawn of time, and they've just been slowly evolving ever since. But is that the whole truth? Do all galaxies actually date back to the very beginning? Or is it possible, just maybe, that some are still being born today, right in our cosmic backyard? Keep that in the back of your mind as we dig into the evidence.
Discovered way back in 1864 by the astronomer Albert Marth, NGC 277 is our prime suspect. It's a highly disturbed, amorphous companion galaxy. It has an incredibly high surface brightness, meaning it is blindingly luminous for its size. But its chaotic, knotty appearance completely defies the rules of normal, structured galactic evolution. It doesn't have those neat, sweeping spiral arms we expect from a mature galaxy. Instead, it looks like a system that is fundamentally out of equilibrium.
Section 1. Examining the cosmic evidence.
Our clues reveal a highly active system that is just packed with extremes. First off, its light is totally dominated by massive amounts of young stars, specifically late B to early A types, which means are only between 100 million and a billion years old, basically cosmic babies. We also see a super hot 60 to 100 micron infrared flux ratio of 0.58, so there's a ton of dust being intensely heated by these recently formed stars. Plus, the gas clouds inside are totally chaotic. They show absolutely no signs of normal rotation. Actually, there's a galaxy-wide expansion of gas rocketing outward at a staggering 1,000 kilometers per second. It's like a powerful starburst wind is just blasting it outward. Oh, and to top the whole thing off, it has a 50% overabundance of neutral hydrogen for a galaxy of its size.
The absolute proof of this youth is right in the optical spectrum of NGC 2777. The data shows deep dips, known as strong Balmer absorption lines. That is the unmistakable, undeniable astronomical fingerprint of very young, early-type stars. This confirms, beyond a shadow of a doubt, that the light we're seeing isn't coming from ancient, billions of years old stars. This is a population that was born, cosmically speaking anyway, literally yesterday.
Section 2. The collision theory fails.
Now, the traditional, textbook explanation for a chaotic, gas-rich, starburst galaxy like this is a gravitational collision. It's the standard assumption. Two galaxies crash together, gas gets compressed, and boom, a massive burst of new stars. And initially, the radio data kind of seems to support that. It reveals a massive trailing tail of neutral hydrogen gas extending directly from NGC 777, stretching roughly 13 kiloparsecs straight back toward its giant older neighbor, Caldwell 48. On the surface, a connecting bridge of gas like that screams cosmic hit and run.
But wait, here is the ironclad alibi. If these two galaxies actually collided or even just had a close gravitational scrape to create all that chaos in NGC 2777, the larger Caldwell 48 should be heavily damaged too, right? We'd expect to see disturbed spiral arms and shared starburst activity. But instead, Caldwell 48 is totally, perfectly undisturbed. It has this beautifully intact, symmetrical dust ring and completely normal, cool infrared emission. There is absolutely zero sign it was ever involved in a collision.
And then there's this bizarre little dynamical fact that really throws a wrench in the gears. According to the data, the gas in that trailing tail is actually moving about 50 kilometers per second faster than NGC 2077 itself. Think about that. In a standard gravitational interaction, where a gas is just being stripped away and trailing behind a moving body, it physically cannot move faster than the object it's trailing from. It's an absolute dynamical impossibility under the collision model.
Section 3. The ejection hypothesis.
So, since the gravitational collision theory completely falls apart under scrutiny, we have an undisturbed neighbor and dynamically impossible gas speeds, researchers Halton and Sulentic introduced a pretty controversial plot twist. And this continuum radio map is their smoking gun.
The contours clearly reveal a fossilized radio jet, an actual elongation of radio emission extending from the center of the older Caldwell 48 directly along the exact same path as that hydrogen stream, pointing right at our chaotic little galaxy.
ARP and Sulentic proposed an entirely different, mind-blowing mechanism to explain the anomaly. Instead of two old galaxies colliding, they hypothesized that older parent galaxies actually eject material outward through powerful nuclear jets. Interstellar magnetic fields act like a cosmic straitjacket, tightly constraining that hot ejected gas. This prevents it from just dissipating into the void, forcing rapid cooling and the massive condensation of dust in young stars. The end result, a brand new, young companion galaxy is literally birthed from the older one.
Section 4. Are galaxies still being born?
So, what does this actually mean for the timeline of our universe? Well, we conclude that there is no evidence that all galaxies are old and considerable evidence that young galaxies exist. That's the direct takeaway from ARP and Sulentic. While this ejection hypothesis definitely challenges the standard astronomical status quo, they neutrally pointed right to the physical observations. The chaotic gas, the baby stars, the impossible tail dynamics, the pristine neighbor. To them, this was observable proof of ongoing galactic creation.
Which leaves us with one seriously mind-bending question to wrap up this explainer. We've seen the evidence of young stars, hot dust, and jet trajectories that suggest galaxies might act as cosmic parents rather than colliders. So, if new galaxies are continually bursting into existence right in front of us, ejected from the cores of older neighbors, how much do we truly know about the age of the cosmos? Are we living in a universe that's far more active and maybe much younger in its ongoing creation than our standard model suggests? It's a fascinating perspective that definitely forces us to keep questioning the stars. Thank you so much for joining me today, and keep looking up.